Yeah. I would say 20 foot for the coil to go through it. Yeah. So, yep. It's neat to see it, and I think microchannel is probably going to be our future, whether we like it or not, because of. There you go. And it's a really good heat rejector. So for a condenser, it's a more challenging to use it as to pick up heat like an evaporator. It's just much more challenging. Good. Yeah, because I mean it's a lot of face velocity to Yep. So yep. So I'm gonna wait for. We're ready to go. All right. Well, good. Thanks everyone for taking a few minutes of time out of your trade show to let me talk to you about the upcoming refrigerant changes. My name's Jeff Warther. I work for the Chemours company. I'm going to be talking to you guys about refrigerants called, it's as simple as ABC. So depending on whether you're dealing with air conditioning or refrigeration, we've got refrigerant for your future. Now I said the Chemours company, right? A lot of people are like, who's Chemours? Bottom line is, if you know Freon, Chemours is a spinoff of DuPont. So we've been in the refrigerant business for over 90 years, and if you know the word Freon, then you know who Chemours is. Moving forward, though, the new name for the refrigerant is going to be Opteon, because we're trying to do this optimum balance of the lowest impact on the environment, the best performing product, the safest product. So that's why we say it's Opteon, or optimal balance of that, and that's what you'll hear from this point forward. Is like if you deal with 449, that's under our Opteon brand. Or when you're talking about the new refrigerants, 454A, B, or C, that's going to be under our Opteon brand as well. But bottom line is, if you know the word Chemours, you know the word Freon, that's the connection. But I just want to spend a few minutes, if you've done any webinars or listened to anything about, our industry, about the regulations, why we're here. And there's two things that the government's been managing, the EPA. One is the refrigerant manufacturers, right? They're basically saying, you've got this bucket of GWPs, or what we call CO2 equivalents. Use them wisely. And so I don't have the percentages here, but in January of 2022, they took away 10% of our GWPs. It wasn't a real big impact on things, but January 1st of this year, they took away another 30%. And so a lot of people are thinking, oh my gosh, there's going to be less refrigerant out there. What I want to try to show you is it's more about this technology transition. So it's moving forward. It's going to be all about the GWP of the refrigerant. Every refrigerant's got a GWP. And so like our 410A has a GWP of over 2,000. January 1st of 2025, residential, light commercial, anything that's using 410A will move to 454B. So now in Chemours' bucket, instead of spending 2,000 of my GWPs to build, say, a pound of refrigerant, I can build over 4 pounds, because my GWP, I'm only using 466 of that bucket that we. Refrigeration, 404A is probably the worst one as far as GWP offender. 1,000 GWP, 404 or even 507 if you're dealing with that in refrigeration. Our 454C product has a GWP of under 150. So if you think about it this way, these look like big step downs, but by us working with the equipment manufacturers, going from a very high GWP to a low GWP, we're going to have more GWP in the bucket to be able to build more refrigerant. Now I will say, as it gets farther out into this timeline, you can see there's another step down in 29, another one in 34, and in 36. If you aren't currently reclaiming, you need to. I mean, bottom line is 410A is going to be worth money. If it's not worth it right now, find somebody that will pay you for 410A, because it is worth it. Because that's the only way that we'll be able to manage this out here when we get down to lower and lower percentages of virgin refrigerant. We're going to need as much reclaim, right? I think like R22, the EPA showed it was like maybe 7 million pounds of R22 have been reclaimed last year. 700,000 pounds of 410A had been reclaimed. So we got to change that, right? But the bad thing is if you're not getting paid for it, or worse, you're being charged because you bring it back and they say, oh, it's burnt or blah, blah, whatever it is, and then they want to charge you to get rid of it. That's going to change. The reclaimers of the world are working very hard to help with that piece. And so if you're not getting a lot for 410A right now, be on the lookout, because you should be able to get money, good money for 410A. Obviously 404 is the same thing if you're doing refrigeration. So you see the phase down. This is probably the first time you've seen something like this. It's more about, this is how we as a refrigerant manufacturer are being managed by the EPA. We get a bucket of GWPs, and I don't want to build a whole lot of 4,000 GWP refrigerant. I want to build a whole lot of this refrigerant. And you'll be able to see that these refrigerants are very, very similar. 404 you can replace with 454C. 410A will obviously be replaced January 1st, 2025 with 454B. All right, so now, of course, it's going to lock up on me, because it can. I did it like 20 times down there and not a single lockup, but that's the way things go. And of course, we're being recorded and all that good stuff, so bear with me for a second.
I didn't sign a waiver.
Yeah, you didn't sign a waiver. Just don't look at the camera back there. That's all. All right, let me get through this. All right, so how is EPA working on the equipment side? And this is where I say January 2025, all the air conditioning equipment that's currently using 410A, January 1st, 2025. VRS, if you do any VRS, January 1st, 2026. Periods and things like that, if it's self-contained, say Friedrich builds a bunch of 410A PTAC units, right? They can do a 3-year sell-through. If it's a field-erected, meaning a split system, right? Coil, evaporator, outdoor unit, and line set, that's only a 1-year sell-through. So this is where you'll have to work with to manage your inventory moving forward. So that's for air conditioning, January 1st, 2025, or VRS, January 1st, 2026. Bottom line, EPA says, I don't care what refrigerant you use, as long as it's a GWP below 700. 7 out of the 8 OEMs have selected R454B. There's 1 OEM that has selected R32. And so then R32 has a GWP of 675, so it is below 700. For those that are in the room that deal with refrigeration, it's a little wider time frame, because with commercial refrigeration, you're like, okay, what in commercial refrigeration? Is it a chiller that I'm dealing with process cooling or something? Is it a food retail where I'm dealing with Hussmann or Hill Phoenix cases? There's a different timeline for each one of those, but the GWP, it depends as well. And so you can see 150, 300, and 700 are the targets for these GWPs. The EPA says, I don't care, Hussmann, Hill Phoenix, what you use. It's just that you've got to select a refrigerant below those GWP values. So this is complicated. This is what the EPA looks like, right? You don't have to worry about this other than what they call sector controls. And in this case, this is a self-contained refrigeration as a chiller, a standalone product. Depending on the fluid temperature, then that's going to be the GWP range. Or if it's air conditioning as a field-erected design, you can see the different things. And so, the Heatcrafts, the Hill Phoenixes, the Carriers, the Reams of the world guide you guys through this. They've already selected the refrigerant. It's just that when and today's thing, really what I want to get you comfortable with is not worrying about the refrigerant. So I am going to use the F word today. I'm going to say flammable. But it's nowhere near what as soon as you hear flammable, they immediately go to hydrogen. I don't want you walking out of here today thinking that these new refrigerants are anywhere near. In fact, what I want you to walk out of today is to say that these new refrigerants are so much like what I'm already dealing with, 410A, 404, that it's that minor of a change that you'll be going through. So, like I said, it's as simple as ABC. That's our refrigerants. It's a mixture of R32 and R1234YF. R1234YF is in all your guys' car air conditioners, right, in the last handful of years. That is an A2L refrigerant. It has a lower flammability. So the automotive industry's already went through this journey. But you can imagine if a hot exhaust manifold on a car and a pipe or a hose would break and 1234YF would spray on a hot exhaust manifold, and that exhaust manifold is not hot enough to ignite the refrigerant, that's what you're going to be dealing with, right? It's not like propane, where you only need 2% propane, 98% air, and something as small as static electricity when you walk across a car of value that can ignite R290 or R600. So these three refrigerants, they have no propane in them. So when somebody hears new flammable, this is only a blend of R32 with R1234YF, and we change the composition. I can do low temp refrigeration with A, I can do air conditioning with 454B, and I can do medium temp refrigeration with 454C. Now, this is a complicated slide. We've got this down in my booth. Bottom line, the light blue are things that you can retrofit, right? You know, you've got a grocery store that's got 404. You could move to 449. If you've got anything like a chiller that's on 134A, you can move to 513. That's probably the easiest retrofit you could do in the industry right now. But the dark blue boxes are only new equipment. So everything I'm going to be talking about, this ABC, these are not replacements for retrofit for the industries. These are, the dark blue are only 449, the 513, you may hear 448. Those are retrofittable. The new refrigerants ABC are not retrofittable.
Excuse me.
Yep.
R32 a flammable, slightly flammable.
It is. Yep. Perfect timing. You get a bonus point for that. Spot on. And hey, back, like I say, I was at Carrier back in the early 90s when we introduced 410A. So our 410A has been around for 30 years. That's hard to believe it's been around that long. But it's a 50-50 blend. R32 is an A2L refrigerant, but the industry was not ready for a flammable refrigerant. So we added R125, which is a flame suppressant. You find it in the fire extinguishers, right? And so by mixing that together, we stayed in this one category, this A1. Everyone's always said it's non-flammable. That's no flame propagation. Second, that's a very important piece of the puzzle. But if it's about going to a lower GWP on this balancing act, you push down on GWP, you push up on flammability. Now, 454B, both components are an A2L refrigerant, R32 and R1234YF. And so the industry it's taken about 10 years for us to create this category because, you know, if you've dealt with R290 or R600, if you do any commercial refrigeration or even, you know, refrigerators in your house, have an A3 refrigerant, highly flammable, right? Very small amount of refrigerant and a very small ignition source. These here, you know, it takes a whole lot of refrigerant and a whole lot of ignition source for either an A1 or an A2L to have what we call a combustion event. And so I'm going to go through some things that you probably have never seen before. I'm going to go a little bit deeper, but I just wanted to make sure everybody felt comfortable with that. This transition for air conditioning is going to be very simple, right? We're not going to talk about any difference in POE oils. It's the exact same oil. You can see pressures and temperatures are very similar. You know, I use the example if it's 100 psi on 410A, R454B might be 98 psi. It's that close. If you've got digital gauges, that's already programmed in there. It's been out for a while. If you've got analog gauges, you know, probably go back to a PT chart or, you know, like Dan Foss has got a really good PT app that you can use. But similar dynamics because, once again, the Carriers, the Rheems of the world, you guys just went through these new M1 conditions, right? SEER2, HSPF2, all that stuff. Nobody had time to redesign. That's why 454B was the best selection, is because they literally could drop it in from a performance standpoint and be able to get very similar things. So you won't see with the new 454B, you won't see a coil getting bigger, where, R22 to 410A, you had different things. Oils are the same, the architecture is the same. What is different, once again, this group in here, I probably don't care a whole lot about GWPs, right? But what it's about is we need to talk about this classification, what ASHRAE does, apples to apples comparison. It's moving from a different classification from an A1 to an A2L. That's why you cannot put in 454B into an R410A system, because the system is not designed for it. And when you go through the training later this fall, you'll find out it's not a big change. But it may be that Carrier or Ream looked at it and said, hey, you know what? We used to have an open contactor. Well, you get a 50, 60 amp contactor and it opens. That's a pretty good arc. That's a lot of energy. What if we put an enclosed contactor on there? Or maybe we don't have so many holes in our control panels, right? Those are the kind of things that you'll see. It's more about keeping the potential for that ignition source to get anywhere near the refrigerant if there's a leak. For those of you that do 404, this is where I said 454A and C. This is 404A is the white line, so both 454A and C actually are a little bit lower pressures, but then as far as capacity, 404A is this blue line here, and then so 454A is a little better, 454C is a little less. It's all about that EPA thing and the GWP, where does it fit? But we've got two great products that moving forward, the Hill Phoenixes, the Hussmans, that'll be in Food Lion, those kind of stores, will move to either 454A or C in the not too distant future. So two things I wanted to come out of this thing is, one, there are no hydrocarbons. I just showed that balance of 454B only has 32 in YF. So when somebody hears the word flammable, you can say that's not what Rheem, Trane, Lennox is going to come out with. It doesn't have propane in it. And so there are no hydrocarbons in the A2L refrigerants. And then the second thing is you cannot use this new refrigerant in older equipment. It can only be in equipment that's designed for the newer classification. All right, so good, I'm on track. This is where a lot of you probably never went through. This is testing, actually, for the refrigerant. Every single refrigerant goes through a similar test, apples to apples, and they use these ASTM testing and ASHRAE. And so what happens is you put a refrigerant in a vessel. There's a little thing down here at the bottom, and it spins and makes sure the mixture is really good. And then there's an electrode right there. And there's R410A. You guys know that R410A, you get a hot enough ignition source, it will burn. And so that's what 410A looks like. R22, R404A, all of them fall within this parameter that as long as the flame did not extend beyond 90 degrees, it's just been an industry standard for 50 years. It says if that flame did not extend beyond 90 degrees, it's called a no flame propagation. It did propagate or extend beyond 90 degrees. Nowhere in here does it say that it's non-flammable, but everybody has been talking about that for the industry forever, right? Oh, 410A is non-flammable, R22 is non-flammable. No, it's just that it stayed within this 90-degree parameter, and so it's got a no flame propagation, which is a 1 category. So we did a bunch of testing, right? We've been 10 years on this journey of making sure that the refrigerant's right for everybody, right? So the fire department, as soon as they heard flammable, they immediately think, big combustion event, right? And so we went to UL and did a bunch of testing. They recognized that R22, R410A can burn. If you've got any family or friends that are in firefighters, actually you can take this as well. It's the FRSI, Firefighter Research Safety Institute. They've got an excellent A2L training program. They show that they light the refrigerants on fire and what happens. Bottom line is the fire department is now treating R454B the exact same way they would treat R410A, right? They've got the PPE, you got to worry more about RCL levels and things like that as far as, asphyxiation. But in a fire event, they're going to treat R454B exactly the same as they would treat R410A. And so the picture on the far right is R454. I think this is actually C in this case. And you can see that the flame extended beyond that 90 degrees. The second it goes beyond 90 degrees, even if it's 91 degrees, it becomes a flammable refrigerant. And that's why we needed to create a category, because not only did it just barely break the plane, but it exhibits the exact same characteristics, meaning that when you have 410A, if it burns and you take your torch away, the flame goes out. That's the same thing with this new refrigerant, is it doesn't self-propagate. Like R290 or propane that's in your gas grill, you know, once you ignite it, it stays lit until the fuel runs out. This doesn't do that. If the ignition source goes away, then the flame goes out. It's a very lazy flame, almost like a Bic lighter, right? You see it whenever you're brazing. You know, you see a little flame come out and you either blow it out or move your torch away and it goes out. It might be a little oil in it too. But bottom line is, these new refrigerants act much more like an A1 than an A2L versus R290, right? That's a big combustion event. You know that if you're using your propane grill, right? You know, you turn on the grill, you turn on the knob, and then you start hitting that red button, and then you hit the red button, and then you hit the red button. You start backing up a little bit, because you know that's a whole lot of fuel that's going in there, and it only takes a little ignition source to do it. These other refrigerants, 454B, 410A, it takes a lot of refrigerant, and it takes a lot of ignition source to be a combustion event. Like I say, a hot exhaust manifold on a car will not ignite R1234YF, right? So people say, oh, I do heat pumps. What about an electric heater? You know, we had to play the what if scenario in this 10-year journey we've been on. You know, what if the blower dies? What if the electric heater clicks on fails? You know, now the coils are cherry red and you blow refrigerant on it. All it did was cool the electric heating elements. The electric heating elements weren't hot enough ignition source to ignite refrigerant. So, yeah, question? Yep.
So maybe a dumb question.
No, it's such a thing.
Are any of these refrigerants available to retrofit to R290?
No, because of, once again, that A3 is a different classification. So, yeah, that's, and you know, R290 is a great refrigerant, but you can only use 5.3 ounces. So that doesn't do a whole lot for you. But, you know, R454C has very similar characteristics to R290, but it's a different classification. You would think you'd be able to go backwards, right? And if it's less flammable, you could put it in, but the ASHRAE and UL, it's more about UL. UL says, thou shalt not move from a different refrigerant classification.
And one more thing, is this presentation going to be available through email or any other means?
Yeah, it's actually being recorded. So everybody in here, and then I think there was actually twice as many people signed up, so you're going to get something from ACR on this presentation. I don't have time to go through this, but if you stop by my booth down there, I'll show you this video. Clifton Beck works for ESCO Institute. He lives real close to me in Indiana, and he does a great job of showing you, right? I can show you all the numbers and tell you all the flames, all that, but Clifton Beck actually went out and found an A1 refrigerant, an A2, an A2L, and then obviously this is an A3. He's got ignition sources, whether it's a spark ignition or a hot surface igniter, and he sprays it on there with vapor and liquid. And you can see that just like 410A, if you get the right concentration, you may see a little flame for a second, but then it goes away. That's what and so like I say, unfortunately I can't do that one here today, but come down and see me. He does a great job of being able, and he found, like I say, these are like computer cleaners, because heaven forbid if I would buy a bottle of 134A and spray it, the EPA would be all over me, right? The de minimis or de maximis or whatever they call that, yeah, I'd be busted for venting, right? So Clifton did a really good job, and so this is another thing, you know, to show your technicians. This is on YouTube, and Clifton actually goes into detail about the refrigerants, what is an HFO, does an excellent job, and I've been using ESCO Institute for my training when I do some, I've been doing some field trials and that. So I'll just stop down at my trade show or my booth and I'll show you the video. I'll have it on a loop down there. All right, so now what's changing as far as refrigerants, as far as the cylinders, right? So the disposable cylinders, there's going to be two changes. Well, actually 3. One, it's going to either have a red band or the entire top of the cylinder is red. That's going to be the first indication that it's a different refrigerant. It's flammable. So R290, right? You've got little red stub outs and things like that. You'll see that on the equipment, but I can't go on the equipment today. But the cylinder will either have a red band or the entire top will be red. We had to do something different. We don't want this refrigerant going in a 410A or a 404A system. So the equipment manufacturer said, we're not going to go to different, left-handed threads on our service ports. We're not going to go to a different size. Like if you're dealing with mini splits, I think mini splits have, smaller. So the industry said no. And we said, well, we got to do something different. So we decided that the cylinder would have a left-handed thread. The very next day, somebody got smart enough to say, I know how to make money. I'll make a left-handed, right-handed adapter. And so you already see those on the shelf, or like Robinair, Ritchie, any of Field Piece, they may be their charging hose, maybe A2L compatible, and that part of the hose would be left-handed thread. It's just that we had to do something different to cause someone to pause and say, oh yeah, I shouldn't be putting this in a 410A system. The other piece, honestly, this is the way it should have been forever, right? Hopefully, has anyone in here ever had a cylinder rupture because of heat? Good, I'm glad. Because I've traveled all the US and I only have one person so far in my training. But that rupture disc is literally saying if the pressures get too big, just rupture. Just rip open, dump all the refrigerant out, and that's it. It's a cheap way for a safety on a cylinder. What is going to happen moving forward is it's something called a relief pressure valve. It's only going to open long enough for the pressure in that cylinder to get back to a stable condition and then reclose. So when we talk about managing the refrigerant and stuff, it's a great way to do it. And so like I say the rupture disc, bottom line would just let all 25 or 30 pounds out. This resettable pressure disc is only going to say if the pressures get too high, open, and then close back down. So honestly, I would have liked to have that back, I believe it or not, I actually started my 40th year doing this. I started out as a technician with Kroger's, and I had the grocery store right across the street from Copeland. So I was trying all kinds of crazy refrigerants, scared the what out of me, but now here I am peddling it. Selling it. It's just, but I really do believe it's getting simpler with ABC. I really do believe that 3 refrigerants, just changing the composition, will be a lot better. The cylinders are better because now you got a safety relief valve, right? All right. Service trucks, right? You've heard all kinds of crazy, oh my gosh, I'm going to have to put placards on all my trucks. Oh my gosh, I'm going to have to do this. If you look under the U.S. Department of Transportation, under something called the Materials of Trade, we've worked with the DOT and all that, as long as you've got less than 440 pounds of stuff on your truck, right? You're carrying an acetylene, you're carrying all kinds of other chemicals, right? As long as it's less than 440 pounds, you'll be able to carry 454B in your truck, just like 410A, or 454C, just like you're carrying 404A. And so, now obviously, if it's a bigger, if you're picking up a whole skid, and you've got a flatbed truck or something, that placard's going to be needed. But now I will say this is the Department of Transportation, right? But sometimes local municipalities, right, common sense will not be tolerated, and they may say that you need a placard. So you just need to check with your local municipalities. But like I say, from Chemours' perspective, we're saying that the Department of Transportation has permitted R454 A, B, and C to be transported in service trucks with no difference. Okay? All right. So let's talk about the installation piece, right? This is what, when I was at Carrier, I wrote installation instructions. And a lot of times we would say, we recommend that you purge with an inert gas, right? Why would you do that? It's because you don't want the black scrunchies, right? You don't want the black carbon in there that's going to clog up TXVs or mess up filter dryers, right? But we would say we would recommend. If everybody in here is already doing the best practices, moving to these A2Ls, the instructions are just going to say required. We're requiring it because if you know about a combustion event, you need fuel, or in this case refrigerant, you need a hot enough ignition source, and then you need oxygen. If you purge with nitrogen, you have no oxygen. So even if you have refrigerant and you have a torch, if there's no oxygen, you will have no combustion event. So it's really just getting back to the basics, but if everybody in here is already doing the best practices, you're going to find out that most of this change is going to be best practices moving to required. And a lot of, like I say, I did the R22 to 410A transition, and we scared everybody back to the basics, right? Oh my gosh, you got to do a good evacuation. You got to do these different things because of the POE oils and stuff like that. And believe it or not, warranties actually went down for a handful of years because everybody was nervous about the transition. That's what we're going back to the basics. But if you're already doing it, you know, this is not going to be a very big change. So that's all I had. Actually, I went through much quicker than I thought I would. I'll open it up to questions, right? Does anybody have questions come in here and wanted to know something about the refrigerant itself? Yes, sir. I'm sorry, I can't hear very well. 513. Yeah, so 513 is an excellent replacement for 134A. It is 30% 134A and 70% R1234YF. But we were able, when we did the mixture, we kept it in an A1 category so it can be retrofittable. So if you look at moving forward, like the trains and everyone in the world that were using 134A or Carrier just announced too, they're going to 513. But if you've got any equipment that's on 134A, it's probably the easiest change that you could ever make. It's literally pull it out and weigh in the new charge. It's that simple. So I've actually got instructions. If you want to stop down at my booth, I can show you. There's a PDF on the conversion. It's about a 10-page document that just walks you on that journey. So if you've got anything 134A, I'm working on gas methane plants, 7,000 pounds of 134A. Well, we're doing with 513 now. So, yep. So, yes, sir. Yeah, please. Yes, sir. Yeah, I mean, yeah, Goodman was in a tough spot, right? They own R32, right? And so it's kind of hard for them. But I do believe that like one of their platforms, like the Rebel platform or something, is going 454B because they don't want to change. But R32, it's a pure refrigerant, right? It's a good refrigerant, but it's got a GWP of 675.
Barely under the.
Just barely. And so that's where the Carriers, the Trains, the Lennoxes of the world said, you know what? We want the lowest GWP refrigerant possible with the same performance as 410A. And so that's why almost everybody has picked it, and it's not a different change. Don Gillis, who's one of our trainers as well, he came from Copeland. And R32 has a higher discharge, I believe it's temperature. And so Copeland was struggling with that. So with R32 compressors, I think it's actually a different oil. Like if you get close to 225 on the oil with POE oils, or at least the current one, things start happening, I guess. So could I see Daikin eventually go to 454B? Possibly. Yeah. So yes, sir. Yep.
I talked to Don about that.
Yeah.
About the oil. He said that where 454B would use your normal POE oil.
Yes.
The 32 blend or whatever. Then the R32 would have to use the 68 because it's a higher viscosity or whatever.
Yeah.
And, better resistant to the higher temperature.
Yeah. I mean, for a while, R32 compressors, they were looking at doing some kind of an injection. So I don't know if anybody in here is refrigeration, you know about, injection, and, that would cost a fortune. So Copeland was able to get it. What's that? Well, it's either liquid or vapor, whatever it would take to keep the discharge temperature cooler, Yeah, so, that's a challenge, right? And so, like I say, I think the POE oil that Don described is covering the R32. But to your point about 7 out of the 8 OEMs have selected R454B. It would be nice if the whole industry. But I will say, anything that's built in Europe or Asia, right? You go look at, you buy a window shaker or a window unit from Lowe's, it's probably got R32 in it because 10 years ago, China and Europe and Asia went to A2Ls, and that was their choice. But we're already seeing that transition to 454B because that ragged edge of, the EPA could come back X amount of years later and say, well, things aren't working right. We're going to go down to less than 500 GWP. 454B still fits in that category where R32 would not. So, yep.
So I'm looking at your 3 cylinders here. All 3 of those cylinders look spot on identical, but as you said, one's medium tip, one's low tip, and one's high tip.
Yes, sir.
So what happens if you mix that low tip in with the high tip? If you ask me, one of my guys does that, they're pulling the entire charge out, pulling back and changing drives, possibly placing the oil, replacing all systems.
I would say that the only thing that if you did make that mistake with one of these 3 is you would just have to pull out the refrigerant, pull a good vacuum because the oils are all the same. All 3 of the oils are the same. And then
How long until we start seeing this in supermarkets where I got over 1,000 pounds of refrigerant?
if they put in the wrong refrigerant,
100 pounds would make a world of difference as it affects superheat or PT.
yeah. I mean, but if you put in the wrong refrigerant now, I'm trying to understand what's different.
Refrigerant cylinders now
Right.
are very well identified. Those are identified.
The colors. Okay. Yeah. So I think, unfortunately, the colors didn't mean a whole lot. Like if I would say all low temp refrigeration was in blue cylinders, all medium temp refrigeration was in green cylinders, and all air conditioning was in red or rosé is what 410A is. But it didn't have any rhyme or reason, right? If you look at 513 is a light blue, it's almost the exact same color as R32. It's just that some marketing person picked a color. It didn't have any reference, and so the industry as a whole in 2017 said that we're moving to a gray and that you have to label the cylinders and stuff. And so I agree that it's a challenge. I won't lie that everything you buy to this point forward is in gray cylinders, right?
Wouldn't that an international requirement through ISO or something?
I'm sorry?
Wouldn't it like an international requirement through ISO as far as the change? Wouldn't that what it was?
Well, it was an AHRI guideline. AHRI-N is the deal that deals with the cylinders. And so it was decided in 2017 that everything moving forward would be gray. And I agree, right? Getting back to the PT chart, it's at room temperature, 75 degrees. I put my gauge on it. This is 454A, versus C. But, you're absolutely right. I mean, everything gray, it's going to take a few minutes for them to look at the cylinder and make sure they got the right sauce. Yeah. So
is the refrigerant on the side, I get that it's gray, but
Yep.
I mean, will the refrigerant itself will be like in bold print so we don't have those, or is that what we see in it?
Right.
I get the confusion.
Yeah. No, I mean, that's what's coming out. So our 454B is actually released. And so that is available. ACR can get it, but you don't really need it because there's no equipment, needed. A and C is not released yet because their commercial refrigeration is about a year behind. And so, but yeah, it's gonna be labeled. I know, I hate to say we love it in the box, but we know a lot of times it comes out of the box the minute you buy it. So it's making sure that you mark it or do whatever. You can see whether it's 454A, B, or C.
All the cylinders will be red or 450.
Yes. Yes. So he asked a question about a left-handed thread. Everything in the A2L category. So our competition has got one refrigerant that is, I think it's maybe 455, and that's more for commercial refrigeration. But anything with a red band will have a left-handed thread. So that would be the designation.
Also, the red band will also distinguish with
Yeah.
some of the different refrigerants.
Yes. Yep. It's just going to be an A2L. Yep. Okay. Any other questions? Yes, sir.
Are there any plans for a 410
So 410A drop, if we could have, we would have, because the amount of work that it took to get to these A2Ls. There was one refrigerant out there, R466A, but one of the components was iodine. And there was work done back in the early 90s, to look at that, and it doesn't play well with others. And so, no, as of right now, there is no 410. That's why reclaim is such an important piece of the puzzle moving forward, because there is no drop-in. Now, you may hear somebody say, we got one, and I'm going to lean on quality for just a second, because that's where anytime pressure starts getting put on refrigerant manufacturers, you're going to see bad actors. So anybody in here that is buying the refrigerant, or talk with your purchasing agent, make sure they know where the refrigerant's coming from. Just because it's on the internet and it's a great deal. I've seen cylinders of 134A that were labeled 134A, and we did an independent study for the industry. It had 30% 134A in it. It had 70% hydrocarbon. So back to an R2. That, you don't want that in anything. One time we did it, it was like 40% 134A, and the chemist came back and like, dude, I don't know what it is. It's got the pressures and the temperatures, but so when I was taking a lot of tech calls for the organization when I first came on, I would get guys going, I got high head pressure. Nothing correlates to my, PT charts. I'm getting ready to change the coil. There's got to be a restriction. Oh, hold on a minute. I said, did you put that refrigerant in? And he'll go, no. There's some other company was servicing it, and it's on. I said, if it's possible, can you pull the charge out and weigh a new one in? And I said, if you can do that and you still got a problem, call me back. Never got the call back. So what's happening is everybody in here understands the refrigerant cycle, right? You know how the compressor works. You know how the TXV works, condenser, evaporator. Now you got to be worried about the refrigerant, because if you buy some off-brand or something that's maybe not 134A or maybe not 410A, you own that system until it gets right, and that's where it becomes a challenge, right? If you've done R22 air conditioning and new 22B or MO99, right? It's not perfect, but it gets the industry through the end of the life. I don't see something on 410A's future, because 466A has that iodine in it, and it just doesn't work well. And so much so that the EPA said less than 700. If they would have said less than 750, that 466A has a GWP of 733. It would have fit into the equation, and you would have had an A1 refrigerant for new equipment. The world would have loved it. Trust me. Everybody tried, and it doesn't exist, and that's why we're going through this transition of, hopefully, like I say, stop by the booth. Well, actually, can I go ahead and run it, the video? If it's all right. I thought that I was going to use up more time. That way you don't have to stop by and see me. Clifton Beck does a great job on this. Let's see.
Moving forward, how far out is the R410 going to be available?
Great question. So 410A availability. You install 410A today, we will manufacture that refrigerant through the end of its life, right? It's the difference, like R22 is a phase out, can't make it. R410A is a phase down, right?
It's
Now,
not a phase out.
no, it's not a phase out. The thing is the only thing is it does have 2,000 GWP, so as you're farther out there, we wouldn't want to build too much virgin 410A, so we're going to...
Keep building it. It just might be an elevated cost.
Exactly. But if the reclaim puzzle can come in, that's going to keep the cost down. Exactly. Yep. So let's see. Let me move this thing over.
Okay, before it gets too dark, I wanted to show you what we're going to be using for this experiment. We have our A1, our A2, our A2L, as well as our A3 flammability chemicals.
You may not be able to hear so well.
Three different ignition sources that are going to be common to equipment that we know.
A1, A2, A2L, A3.
Nitride igniter, as well as a direct spark. Of flammable gas.
So this is what everybody wants to see, right? Show me what it's going to do. That's 134A, which is an A1 refrigerant like 410A. An A2, that's a higher flammability, but in the case of vapor, no ignition. 1234YF is an A2L like R32. You put those two together, you get 454B. All right. Now he keeps letting it go of the regulator, but you know once you ignite R290, it stays lit until the fuel goes out. All right. Right.
We'll start with our 134A again, and yeah, there's nothing going on in there. So let's move on to our 152, our A2. Yeah, actually getting just a little bit.
Now that's a higher, A2 is higher than an A2L.
How about our A2L? Yeah.
That's vapor, right? Somebody's like, okay, what about liquid? He'll go through that example as well.
Okay, let's invert this can and see what happens when
Now, liquid.
oh, look at there, a little bit of ignition.
134A, R410A. You put it out in liquid, get it hot, it's going to ignite.
Okay, now let's try our A2, our 152.
Now, you won't deal with this, so I wish you wouldn't show this one, but that's kind of close like propane. 152A is an A2. That's pretty significant, right? We needed to go to a different classification. Now, here's what you're going to be dealing with in the future, 454B or 1234YF. Yeah, this is liquid.
That's liquid.
Yep, that's liquid coming out. And so, you know, with your torch, but if you're purging with nitrogen, no flame. And then, right? So this is where really Clifton did a good job of just showing the basics, right? Just keeping it simple and showing what you're going to be dealing with. It's not a big change. Now this is that higher flammability. It's closer to an A3 or R290, right? And this is the 1234YF. But if you would take that ignition source away, it goes out. All right. So yeah.
So what does all this mean?
Yeah, Clifton does a
Well, it
great
really
job.
means that all refrigerants really are flammable. It just depends on the amount.
Yeah. And so, I mean, Clifton does a good job. It's about, overall, it's about a 15-minute presentation. He goes through what is an HFO and different things. And he does a really good job. But I thought that this short video, or portion of it, just shows that when you hear the F word or you hear flammable, these new refrigerants are much more like 410A than they are like R290. So now as you walk out of here, and this fall you start going to your ream and carrier and trainings on the equipment, you can focus on the equipment and say, yeah, I saw the video, the refrigerants. I mean, the industry builds 10 million air conditioners a year. Do you think that Carrier or Trane would want to build something and worry about flammability or worry about, you know, legalities, you know, of the thing? And so what you'll probably see different with the equipment is you'll see a sensor on the indoor coil. And that sensor is going to say, I smell something. Do something. If the blower's not running, turn the blower on. If you've got a lot of air and a little refrigerant, even if you have an ignition source, it wouldn't ignite. If you're dealing with commercial refrigerant, VRF systems, it's a little, you know, you'll just have that. But it's not going to be a big change from a refrigerant perspective. It might be a little bit. Air conditioning, folks, this is not going to be a big change. Those sensors, from what I understand, are non-adjustable. You know, they're 20-year life. If it does fail, the fault will be the blowers running all the time. You know, but it wouldn't have air conditioning, so that would be the other thing that would shut it down. So, all right. So I'm close to the time. If there aren't any other questions, if there are, me booth. Otherwise,